All right. Hi, everyone. So this lecture is about descriptive statistics, and this is the type of statistics that you'll probably be a little bit more familiar with. So descriptive statistics are really, what does the data look like? What is it generally telling us about what's going on with a phenomenon? All right. So the typical descriptive statistics that you're likely to see are measures of frequency distribution, measures of central tendency, and measures of variability. And between those, you can really get a pretty decent idea of what data looks like that's being collected. Now, you remember that there are certain types of studies that are called descriptive studies. And those studies are studies that primarily focus on giving data that just accomplishes these three goals of describing what's going on for a population. Okay. All right, so frequency distributions. All right, this is just a basic way of generally presenting the information that's there. So you see this sometimes as histograms, sometimes as pie charts, sometimes as frequency tables, like are on the slide. And this could be data for groups, group data or not data, group data, just in order to sort of see, okay, how many people fall into these different categories. Measures of central tendency are statistics that sort of describe what is sort of common for the information that you're looking at in a data set. It's called a summary statistic because there is it's attempting to sort of provide a summary depiction of what that information is. Now, there are three main measures. Those are mode, median, and mean. All right, so the mode is for a set of numbers, the number that is most frequent in that set. All right, so if you look at this set of numbers here, you can say, well, if you count them up, the number that comes up most frequently there is 4. All right, so 4 is your mode. All right. Now, if you add another 1, then you have an equal number of 4s and 1s. So you have 3 of each. All right, and that's called bimodal. That means that there's actually 2 modes in that set of data. And then if you add another 1, well, then there becomes 4 1s in that data set, and then the mode becomes 1. Now, you can measure modes for any type of data that's there. So you could do it for nominal data, ordinal, interval, or ratio data. So it's a generally applicable measure of central tendency. You can use it for any type of data you collect. All right. Then we have the median. So the median is the middle score in a set of data. So in that idea, you would essentially take all your numbers in your data set, you'd order them from lowest to highest, and you'd find which number comes in the middle. Now, sometimes you have an even number of numbers, and if that's the case, then you can average the two that are in the center. Now this is useful for ordinal, interval, and ratio data. However, you can't use it for nominal data, right? Now, why can't you use it for nominal data? Well, say you have people who have red hair, brown hair, and blonde hair. And you say that red hair is number 1, we're going to count that as number 1. Brown hair is number 2, and blonde hair is number 3, okay? Well, say you get a whole bunch of people with blonde hair. Say almost everybody in the sample has blonde hair. And you say, well, the average for this is 3, right? Or the median for this is 3. Well, what does that actually mean? We could have just as easily assigned 1 to blonde hair as 3. So it just doesn't make any sense to really rank these numbers because in this case the numbers are completely meaningless. They're just assigned to the different factors and there's no ranking between hair color, right? So this is actually fairly important to recognize that nominal data really can't be analyzed by these higher measures of central tendency. All right, so then we have the mean. Now the mean is the average of all the scores that are in the data set. All right, so you essentially add them all up, divide them by the number of scores, number of numbers, and you get an average there. So this is the most stable measure of central tendency because so if you add more numbers and things like that, it's the least likely to change over time. But you can only use it for measures of interval and ratio data. Now, why can't you use it for ordinal data? Well, the reason for that is, if you take something like, let's go back to socioeconomic status. Remember, you have different intervals between these different categories in socioeconomic status. Even if you can rank them from lowest to highest, your top level there might be 150,000 plus. Well, what if Bill Gates is in, that sample? Well, you could have any number in that large category for the upper group. So if you average it out and say, well, the average income for this group of people is 50,000, well, you might not be capturing at all, the actual variability in your sample. All right. So you can only use the means for interval and ratio data. Now, this might seem simple, but it's actually fairly common where I go into some papers that maybe haven't been reviewed very carefully, and I actually see published papers where they report means for things that are actually ordinal data. So it is something that you need to pay attention to. All right. So here's just a little bit of practice. So take a look at this. What is the mode, median, and mean for the following numbers? Okay, so it would be the mode would be 1. The median would be an average of 1 and 2, right? Because those are the two central ones, so that's 1.5. And the mean would be the total number, which is 12, divided by the total number of numbers there, which is 6. So you get a mean of 2. All right, you can tell that I hadn't calculated it out before I pulled that slide up. All right, anyway, here we have the data distribution. Now, when you think about the numbers that are there, this is a histogram. It's very common for a lot of data that you have sort of a normal curve, and this is found in nature very often, where you towards the center you have the highest peak, and it sort of peters out to the end. Now, the assumption of a normal curve is that it's unimodal, so there aren't multiple peaks in it, and also that it's generally symmetrical around the mean, that there isn't doesn't tail off in one end on one end or the other. So, for this, a lot of data, you really need to know whether or not it actually fits sort of the category of a normal curve. Because if it's skewed, you actually can't do certain types of statistical tests with it. So skew is when you have something that is skewed off to one side or another. So the negative skew, for example, it's sort of the tail comes off to the side on the left. Now, an example of this might be skewed data you might expect for age of death, where you'd have some people dying as you're going up in terms of age, and then you have this peak, and then an age at which you typically don't see people living above 100, for example. So data like that would typically be skewed data. All right. So if you're going to try and measure how much variation there is in a set of data, there's a few different ways you can do it. One is range, and that would just be where you present to people the lowest and the highest number in a data set, right? Another way of doing this is there's a semi-quartile range, and this can present actually a better picture of a certain data set, because essentially what you're saying is the lowest and highest number for the middle 50% of a data set. And what that does is it gets rid of those outliers like the Bill Gates in the sample, right? And it gives you a more accurate presentation of what generally that data set looks like. Now, the most common measure of variability, right? So once you have that measure of central tendency, you want to describe, all right, how, especially for a mean, you want to describe, all right, how much variability is there around this mean, all right, so that you can visualize it, all right? So standard deviation is a number that can describe that, right? So the smaller the standard deviation, the closer these scores generally are to the mean. All right. If all the scores are exactly the same, then there would be no variation. So the standard deviation would be 0. All right. So here, let's look at a normal curve. Okay. So you expect to find, so for standard deviations, one standard deviation is about 68% of the sample should be found within that. And that's plus minus 34% roughly. All right. Now, if you go out to 95% or 2 standard deviations, you add on another 13.5 on either side. And then you'll have as you go out on that curve, you'll have another 2% on either side for 3 standard deviations. So when someone says, you know, one standard deviation is 2.5, you can know that, plus minus 2.5, you can know that given your mean, that about 68% of your sample will have a number plus minus 2.5 of that mean, okay? All right, so here's a chance to look at practice doing this and practice doing your standard deviations. So if you had a measure of death anxiety that resulted in a mean score of 5.4 with a standard deviation of 1.6, where would 68% of the scores fall on this measure? All right, so you take 5.4 and you subtract 1.6, and you also take 5.4 and you add 1.6. Okay, so what would that look like? Well, you'd have an answer between 3.8 and 7.0, right? So now, if you were to say take 2 standard deviations, which would be 95% of the sample, what would it look like? Well, you'd essentially do the same thing, right? So you'd subtract another 1.6 and add another 1.6, and you get a range of between 2.2 and 8.6. So that's what standard deviation is as you're looking at it in these tables, right? So it's a helpful way for you to look at these numbers and then say, okay, what does this data actually look like? How much variability is there in this data? All right, so this is just a little chart that's helpful for saying, okay, what types of information can you get from different levels of levels of measurement for measures of central tendency and deviation as well.